Welcome back to the TimCo Retail Manager course. This course focuses on real-world application development. Basically, this is practice for what you'll be asked to do in the real world. In this lesson, we're going to be adding caching of our sales data using local storage so we can eventually have offline access using our progressive web application feature of Blazor WebAssembly. Now, for those of you who are subscribed to my Patreon, at the $5 per month level or higher, head over to get a copy of today's source code. That'll give you a good copy to compare to your code in the case you run into an issue. So let's jump right into Visual Studio and pop open our portal project. This is our Blazor WebAssembly project, and we're going to start adding in offline access. Now, we already have the progressive web application elements already configured in this, or at least initially configured. So for instance, you'll see here we have our manifest.json and we have our service worker that we'll be working with, and that'll probably be in the next week or two or next lesson or two as we get into further down the road. But first we need to set up some caching, which will not only help with offline access. That is a big deal and a need for offline access, but really the bigger thing actually is going to be the fact that when we do caching, then we don't have to ask the API every single time in order to get new data. So let's start off by talking about how we're going to talk to local storage and what local storage is. If we were to run a web application right now and look at, in fact, let's do this. Let's run this right now, just so we can have a web app up and running. And it thinks it wants to know about Docker. It doesn't want to know about Docker. That's okay. We can work with that later. That's actually not what we're working with. So let's actually stop that and start it again. Okay, that's what I get for testing with Docker. Actually, what happened was it messed up this file right here, which if you have keen eyes and notice the launch settings.json has a little red icon right there. And what that indicates is that it's not tracked by Git, which is both good and bad. So it's good because this is all personal stuff. This is for my local testing environment, and it can be different for your machine versus my machine. So having it be different is great. The problem is that because it's not tracked by Git, if you make any changes to it, you cannot roll it back with Git. And I have been testing around, playing around with Docker, and we're going to do some Docker stuff with this project. And so I had added Docker to the project and made some changes, but what that does, it does change the profiles for launching this application because it prepares to launch it into Docker rather than as either Docker or local. So with that being said, I think I have it back to where it should be now. Let's launch this again and see if we can't get it to run correctly. So here is our Blazor WebAssembly app running. We can't, of course, go to our product page. We don't have access to it. And if we hit F12 to go to the developer tools, if you're not on Windows, you'd run this on Mac, then the developer tools might be different for you, what the command is for that. But for Windows, it's F12 usually. So in here, we can look at application. We have here local storage. We can see there's nothing in local storage right now. We have session storage as well. So let's talk about the difference here, because there's two kinds of storage attached to the same website. So this URL, localhost 44390, that specific site will have two places to store data: local storage and session storage. Now you can store with IndexedDB or other things, but when it comes to storage itself, local storage and session storage is where it's at. So the difference is session storage only lasts as long as the browser session is live, and it will change if the browser session does, which means that if you have two different clients open, or I'm sorry, two different tabs open, then they will have different session storage. And local storage is going to persist not just between tabs, but also it'll persist even after you close down the browser and start it up later. This is the type of caching we're going to use, local storage. So we'll put stuff in here in a key value pair form. So that's what we're going to use for our caching. And it's built right into the browser. And if you were running JavaScript, it'd be super simple to do. With Blazor Server, it's also super simple to do, but we're not using Blazor Server. We're using Blazor WebAssembly. And WebAssembly is a little different animal because it runs fully on the client. But never fear, there is an easy way to do this. We're going to hook this up in just a minute. So let's start by right-clicking on dependencies and say Manage NuGet Packages. And we already have Blazor Local Storage installed. Excellent. So we'll go ahead and make sure we upgrade that to the latest version. That's a little out of date, 3.0, and there's 4.1.5 is the latest. So let's update that. Make sure you have the latest version of this. Okay. So with that latest version now, we could upgrade these other things too. We probably will pretty soon. In fact, let's just go here, and it's these three. I don't think these are breaking changes because they're just minor revisions. So we'll go ahead and upgrade these since they're, again, minor changes. If you had, not even minor, they're patch changes. If you had minor changes, you might want to consider a little bit stronger. Maybe you'd wait for a little bit. And if you had major changes, don't change it. Not until you are going to do extensive testing. So, and really you're going to do testing on even the smallest things. But for us, I think we're good. All right, let's go to our program.cs. And we already have local storage here set up. That's this using Blazor local storage. And down in program.cs down here, we're going to have under services, Blazor local storage. So we already have this set up. And the reason we already have it set up is I believe we use it in authentication. Let's see, authentication services. We bring it in right here. And then right there we use it. We store the token. So actually we would have seen that if we'd store the token and got it back out. So we're already using it a little bit, but we're going to go over to our pages and look at this products page. So let's first bring in the local storage. So inject, and we're going to say this is the Blazor dot local storage dot I local storage service. We'll call this local storage. I think that's fine. So it's going to bring in this variable now. It's going to be injected from our dependency injection system. And then down here, what we're going to do is we're going to come down here to our lookup, where right now our lookup is saying, hey, let's go ahead and get our products. The problem is that when we're offline, we won't have access to do this because we can't talk to the API. So let's do this. Let's put a little bit of space here. We're going to first go to local storage and see if it's available. And if it's not, then we will call this get all. Okay, so let's do a really simple setup. We're going to say products equals await local storage dot get items or get item async. And we're going to ask for a list of product model. Okay, that's what we're looking to get out of this. And we need a key for this. So that key is the name. And let's call this product list. Something like that. And we could even do a, and let's do this. Let's come up here and create a private const string, and we'll call this product, actually Pascal case for constants, product list. product list name equals product list, like that. And then we can use that constant here. Okay, that way it's just a little bit better because we can use this over and over again instead of remembering this magic string. Okay, so right now we are loading the item asynchronously from local storage if it exists. And that's important here because what's going to happen is it's going to return null if it does not exist. Because right now what's going to happen is it's not going to have anything in local storage, so that'll be null. So then what we can do is we can wrap this. So let's just cut it out for now and say if products is null, then we'll load products from the API. And then what we're going to do is say await local storage.set item async. And we're going to set the item based first on a key, which is going to be product list name. And then our value is going to be products. Okay, and that's going to save products into our product list name. Okay, so it's going to do some serialization here to convert this list of product model into a string and store it in this key, which is product list, in that key for local storage. Okay, so now we see if it's in local storage. If it's not, then we load it from the API, and then we store the value in local storage for next time. Let's see if this works. Hopefully it does, but the first time you run things, it doesn't always work. Put our username and password in. And log in. Now we're logged in. We can go to the products page. We've got our two products. Now if we hit F12 and go to the application tab and look at local storage, we're going to see two different things. First, our auth token. That's our authentication. We also have, though, the product list element. And notice here, let's zoom in a little bit. We've got an array that has all the information about our products. All right, so two products, and here's all the data for them. So with that, we now have it in our local storage. We're not going to have to go back to our API when we call it again. It's already there. So we're not hitting our API again. We're just going to the cache to get that data. And a quick way to prove that, if we go back here, this is all editable. Okay, so if I were to come here to product name and say 12 and loop batteries, okay, that's been changed. So now we go back to products. Notice it says 12 and loop batteries instead of 8 because it's going to the cache, not to the API itself. Now, if we hit F12 here and right click on this and say delete, and then go to home and come back, it says 8 and loop batteries because it went to the API to get that because we didn't have anything in the cache. But now we have that product list back in the cache, and it is that refreshed value. So that's kind of our first step in caching data, but we're not quite done yet. So let's close this all out. What we have right now is basically an everlasting cache, which means that if anything changes on the server, we won't see that because we're not actually going to the API again to ask for new products. We're only ever going to the cache if we have a cache value. That isn't ideal, so let's figure out a way to get around that or improve that. So let's create another constant here, private const, and this is going to be a string again because it's the key value or key name, and this is going to be the cache date. All right, we're just going to call this cache date, or maybe you should call it product cache date. Because if we have more than one cache, we want to make sure that we differentiate. So this product cache date, what we're going to do is we're going to, whenever we write to local storage, we're also going to save the date and time in which we cached our data. Then you make a call about how long do you want to wait before refreshing the cache anyway. So let's say await local storage.set item async, and we're going to say this is the product cache data, and we're going to say date time dot UTC now. And we're going to do just that because that will give us the a time zone unaware, just universal time code. That way we don't have to worry about if we, close our laptop down on the East Coast of the US and open it back up on the West Coast of the US, and how does that work with time zones? Not gonna worry about it. We're gonna use UTC. Because we're just trying to figure out, based upon our UTC now, how long has it been since we cached this data? So let's do just this for now, and we're gonna run this again. So we'll hit start, and we're just gonna make sure we can look at the cache and say, yes, it's actually storing that information in the cache. So let's log back in. And once we log back in, no, don't save it. We can go to products. Our products are there, great. If we hit F12, we'll see that we have the product cache date now. So we have this full date time of when this product was cached. Excellent. So now we can go back here and look at how can we use that date and time to gain more information about this product. So let's next create a date time with a question mark at the end. That means nullable, meaning we can have a null version of this. We're gonna say that this is the cache date, and we'll say equals await local storage get item async, and we're gonna ask for a date time. Actually, we're gonna ask for a nullable date time, and we're going to say that the product cache date is what we're looking for. So we're gonna ask for the nullable date time for our cache date, and based upon that, we can make a decision. So now I can say, hey, if the cache date doesn't exist, so or cache date is null. If that doesn't exist, then we don't rely on this cache data. We go ahead and get the API data anyway. So this will first make sure that we actually have a cache date that's valid. Let's verify this is true as well. Now, debugging in Blazor WebAssembly is always a little tricky, but we can make this work. So what we're gonna do is we're gonna start this up and play around with that cache to delete different things that wouldn't normally happen in theory, but we wanna verify in fact what's happening, okay? So first of all, if we go to the page right now, it should be pulling from the cache. Let's find out if that's true. So we're gonna open up our cache and we're gonna modify our products. Actually up here, we're gonna modify our product to say, again, that 12 end loop batteries. So now if we come over here, it says 12 end loop batteries. But now what we're gonna do is we're gonna hit F12 again, we're gonna delete the cache date. Not the product list, just the cache date. Go back to products, and now notice we have 8 end loop batteries because it went ahead and recreated this cache list, and it also updated or added now the cache date back. So now we know that yes, this is working. It is checking for if that cache date is null or not. And if it's not null, or it is null, then it goes ahead and refreshes the cache anyway. So that's another step in the right direction. We're gonna keep working this problem one step at a time. The next thing is, hey, we want a time span in which we say, hey, if it's been more than X amount of time, then we want to refresh the cache anyway, even if it's cached. So let's first figure out what that time is. So let's come back up here and we're going to write some date time code. And date times are always a little tricky if you haven't used them for a while, or even if you have, because time zones get in the way and other things get in the way. So this is why I'm using UTC time, because it just makes things easier and a little simpler when everything's a little hard. So let's start off with this. We're going to say datetime.utc now dot subtract, and we're going to subtract the time, the cache date. Now it's going to say, hey, you can't do that because this is nullable and we can't convert it to not null. So we're going to wrap this. We're going to wrap this in if cache date is not null. And actually, you probably do this in here since we know it's not null. Actually, let's do that. Let's do it right inside. Because we already know that cache date is not null. Therefore, we can do some work in here and say, hey, subtract cache date because it's not null. Well, actually, my bad. Because no, we can't, because it is null that comes in here potentially. So we could put an else here, but let's come back up here. Good thought, but not going to work. So if cache date is not null, then we're going to do datetime.utc now.subtract cache date. But it still says, hey, you know what? You can't do that. It's still a nullable date. Even though we verified it's not null. So we can say here is, this is actually a date time now. Because the only difference between a date time and a date time that's nullable is if it's null. Otherwise, they're the exact same. So we can just cast this to type date time. We said, okay, now I want you to subtract this cache date from the current time. And that's going to give us back a time span. So we have this time span to work with now, but what do we do with that time span? Well, we can say dot, and then we can say, all right, total, probably not total milliseconds, that's probably a little short. We can say total minutes, or we can say total hours. And that's probably what we want to do, is hours or days. Now, there's also in here, just so you know, there is hours. That's different. Hours is going to give you just the hour component of the time span. So let's say that the difference between the cache date and now is 3 days. So it's been 3 days since the last time, well, let's be more specific, 3 days, 2 hours, and 5 minutes since the last time we loaded this cache. Well, the hours property will say 2. It's 3 days, 2 hours, and 5 minutes. So the hours will have just the hours component, whereas the total hours will have 38, and actually 38 point and whatever, I just said what, I said 5 minutes, so whatever, 0.08. So you'll have 38.08 because 3 days, 2 hours, and 5 minutes equates to a total of 38 hours and 0.08, which is about 5 minutes. At least if I did my math right. So that's why we want total hours, because it gives us a fractional value, a double, that gives us all of the hours in this value. So if you're looking at, hey, the cache is going to get refreshed no matter what if it's been more than 10 hours or 3 hours or 1 hour. Cool, go for it. Or if you want to shorten this up, you could say total minutes and say, hey, if the cache has been, if it's been more than 30 minutes or 15 minutes or 5 minutes, it's up to however many times you want your API to get hit. The shorter the cache window is, the more often your API gets hit. The longer the cache window is, the more time there is between when you publish a change and when the user sees that change. So there is a trade-off here. So let's do this for hours. Let's not be too aggressive with this. Let's say that our cache is going to live for a total minutes of, let's say 10. Okay. Now I'm going to put this in a variable, but we don't have a variable in here. We can't put a variable in here because then it would only live inside these curly braces. So let's do a total minutes out here and set to 0 initially. And then we can copy this and paste it in here. And now, whoops, it should be a double, non-integer. And now we have captured the total minutes between the two values. So now we can say, or total minutes is greater than 10. So it means if it had been more than 10 minutes since the last time you ran, even if the cache is not null, even if the products are not null, go ahead and run the update or call the API again anyway. This will keep our cache fresh. Let's make sure it works. We're going to modify the date and time. So let's load the page. There we go. And if we hit F12 right now, we'll see that let's modify our products to be, again, a 12 instead of the 8. So go to the products page, and sure enough, they're 12. All right. But now let's go back to home, back to products. It still says 12. But if we modify this time, let's modify this time to be 1:51. And so we're going to change it by 1 hour. Go back to the products page and notice we have 8 and loop batteries again, and the time has now changed to 3. We've gone more than 10 minutes. I actually changed it to be an hour. So it's actually, way more than 10 minutes. And I said, okay, no problem. We'll go ahead and call the API. So now we have this caching strategy where we cache our data, but then it expires after about 10 minutes. But we still have one more step to take, and that is, what if we are offline? Because, yeah, we want it to expire every 10 minutes, get the fresh stuff, but if we're offline, we can't get fresh stuff. So we're just gonna say, hey, there's no products, or we're gonna at least show them the last products we had available to us. I think we wanna show them the last products we had available to us, but that means we need to figure out a way to say, hey, if you don't get the products, just use the ones you had. And the way to do that is to wrap all of these 3 lines to wrap with or surround with, and we'll say we're gonna wrap with a try. Okay, so now we have a try catch in here, and we're gonna catch this exception, but we're not gonna throw it again, and we don't really have anything to do with it for right now, so we're just gonna say console write line ex.message. So we'll write the message out to the console. That's not the best thing to do. You actually have a logger here, or something that said, hey, we're offline, or something of that nature. And we probably only want to capture the message that comes back and says, I can't find the API. Only want to capture that one and say we're offline. The other one should say, hey, there's a problem talking to the API, or you're not authorized to talk to the API. But for this, I think this will work. We're just going to wrap the whole thing in exception and call it good. Now, the best way to simulate this is actually to throw an exception right now. So let's right here, we're going to throw new exception, test exception. And what that'll do is it's going to throw an exception if we ever get to this spot right here where we pass the check of the products are null, the cache date is null, or it's been more than 10 minutes, which right now is not true. We don't have any of those failing right now. So we can go to products page, pulls up no problem. If we hit F12, we can see all 3 values here. We can modify this cache to say 12. And if we go off the page and back on the page, sure enough, it says 12. If we refresh the page, it's going to say 12 again. It's still working offline. However, what if we delete the cache date for this? Okay, so let's right-click and delete the cache date. Now go back to home and back to products. It still says 12 and loop batteries. Why? Because it's failing to connect to the API. We're getting that exception. So we have this, and it's right here. test exception. So there's our exception right there that we threw saying, hey, can't talk to it, whatever. We're simulating a problem. And so it says, yep, I can't do that. So even though I don't have that date time, I'm still going to show you what I do have. I do have a list of products. Now, if we didn't have a list of products, it would show nothing. It would say, hey, no products. But since we have products to show, even if this isn't an old list, even if it's a year old, it's still going to show this because at least it's something. Now, for a list of products, that's probably fine because you couldn't do a purchase till you came back online. So then we actually verify at that time, is that product still available? For other things, that wouldn't be ideal. So this is not something you just cookie cutter, copy and paste into every situation. You have to think through the caching strategy for everything you do. Some things, not a problem to cache it and cache it long term. If you have a list, if you're in the US and you have a list of the states, we have 50 states in the US, that list probably isn't going to change for a while. So therefore, you could probably cache that list for a day or a week because it's no big deal. It's not changing anytime soon. And if it did, you're going to get a week out of date at most. So not a big deal. And you can actually change it early, knowing that it's coming soon, and then you'd have all your lists updated. So that's not a big deal. But things like the latest information that is mission critical, maybe you say, hey, it's just not available right now because we're offline. So you have to figure out what your caching strategy is based upon every bit of data that you're caching. So with that though, we have our caching in place so that we're ready to go offline with this data. We're almost. There is one thing we have to think through, and that is with this right here, we're loading the product image, but we're pulling it from the API's location. Well, we don't have that API available to us if we're offline. So we're going to have to think about, do we pull those images down and cache them as well? Or do we just fall back to our dummy images and wipe out the product images that are in our offline data? That's going to be a question we think through in the next lesson. But for right now, we're going to say that we're good for caching our data offline for at least the data portion of it, okay, using local storage. So it's not a big deal to use local storage in Blazor WebAssembly. It's just thinking through how you cache that data so that you do so efficiently and so that you don't overburden your API. And at the same time, you don't give the customers a false sense of security, thinking there is data there when maybe it has changed. So you want to make sure you balance how often you talk to your API. The cool thing is, with this, if we find out that we're hitting our API way too often and the caching isn't a big deal, we could just change this to 5 and have 15 minutes, push this update out, and now we've decreased the load on our API server significantly. On the other hand, if we find it is a problem and our API is not having problems, we can change this to just, instead of 10, maybe make it 5 minutes or 1 minute. And we could increase the calls to our API, but have fresher data for everyone. So it's really up to you, but it's very configurable very easily to modify how this caching strategy works to best fit your production environment. The big thing I hear about, performance tuning is, hey, we need to, tune this for the best performance in development. And yes, you should pay attention to performance in development. But there's also something to be said for what's it like in production. Because sometimes you can spend an awful lot of time and write some really complicated code to save what might be a 0.001% performance boost, or to get that performance boost. But you may leave something else on the table like this, where you change it from, maybe it's originally 1 minute, and you go, yeah, we can get by with 10. And that change right there, one character, can dramatically improve your performance across the board because your API is not being hit as often. So you got to think about production. What are your users doing? How are they doing it? You can't just tune in development. You have to tune in production as well. And that's where knowing these kind of things will really help you hit that balance. All right, I'm going to bundle this up. I'll go ahead and commit our changes, and then I will send them over to the Patreon site for those of you who are Patreon members. If you're not a Patreon member, no worries. I did everything on screen. There's nothing I did off screen except for fix my bug that I created off screen as well. So you can just follow along and have the same stuff that I did without having to buy anything or pay any money through Patreon. Okay, so that's it for this lesson. In the next lesson, we'll deal with those images, and we'll start moving even further down the path of getting to a progressive web application where we can have offline access, we can have our custom logo and all the rest set up so that this works like a desktop application on a desktop, and it works like a mobile application on a mobile device. So really cool stuff. We'll tackle that in the coming lessons. All right, until then, thanks for watching, and as always, I am Tim Corey.